Today we are going to learn mm, one of the most important topics, conjugate surds, how to rationalize the binomial quadratic surds. So, what are conjugate surds? The sum and difference of two simple quadratic surds are called as conjugate surds. For an example, let us take root 3. Root 3 is a simple surd. Root 2 is also a simple surd. I will add these two surds and I will subtract the same simple surds which I have taken. Now this addition and subtraction makes these two as conjugate surds. Now they are called as conjugate surds. So sum and difference of two simple quadratic surds is considered as conjugate surds, and we say that they are conjugate to each other. They are also called as complementary surds. Now I'll give you one more example and then we'll continue with the rationalization of binomial quadratic surds. What are binomial quadratic surds also I'll be letting you know. Okay, right. Now four more examples. So general example, we will take root x plus root y. Let us suppose these two are simple surds, and if you subtract them, so this is also a simple surds. So these two are called as conjugate surds. Okay. Now one important thing you should note is when you multiply these conjugate surds, they give a rational number using one of the most important identities, that is a plus b multiplied to a minus b equals to a square minus b square. This is the identity which makes the product of two conjugate surds a rational number. See, let us example root 3 plus root 2, when it is multiplied to its conjugate surd, which is root 3 minus root 2. So this is in the form of a plus b into a minus b, which gives you a square minus b square, which is equals to 3 minus 2, which is equals to 1. Is a rational number. This is a rational number. So when you multiply two conjugate surds, you are going to get a rational number. This is one of the most important thing we need to know. Next, let us learn what is rationalization of binomial quadratic surds. First of all, binomial quadratic surds. What is the meaning of binomial quadratic surds? Very simple. Sum and difference of two quadratic surds is nothing but called as binomial quadratic surds. Sum or difference of two quadratic surds. The most important word is quadratic. So simple. I'll show you an example. Root 5 is a simple surd which is quadratic because its order is 2. Here nothing is there, means the order is 2. Now root 3, this is another quadratic simple surd. Now if you add them, this is nothing but binomial, because two terms are there, it is binomial quadratic surd. So this is binomial quadratic surds. Two simple quadratic surds, if you add or subtract, then it is called as binomial quadratic surds. And one more example, you can write 2 root 3 minus root 5. So this is one more example of rationalization, binomial quadratic surds. So now we will discuss how to do rationalization of binomial quadratic surds. It's very simple. We need to multiply with the rationalizing factor. In order to make any binomial quadratic surd into a rational number, we need to multiply with the rationalizing factor. What is rationalizing factor? What is the rationalizing factor? The surd which is multiplied to get a rational number is nothing but called as rationalizing factor. Now what in this particular case, what is the rationalizing factor for the binomial quadratic surds? Very simple. We already saw that the conjugate surds when multiplied gives us a rational number. So that concept we'll be using here so that we can rationalize the binomial quadratic surds. I'll show you an example here. So let's take an example of root 5 minus root 3. This is a quadratic binomial surd. Now, I need to multiply this surd with another surd to get a rational number. What is that another surd? We already discussed that always the conjugate surds of simple quadratic gives you a rational number. So, root 5 minus root 3, when it is multiplied with root 5 plus root 3, gives you root 5 square minus root 3 square. This is because the identity is used a plus b, a minus b times a plus b, that is a square minus b square. You will get 2. 2 is your rational number. So in order to multiply, in order to make any binomial quadratic surds to a rational number, we need to multiply with its conjugate. Okay, so now let me solve a simple problem here. Most of the questions we have denominator surds. We need to rationalize the denominators in order to simplify them. So I'll let you know with one example how to simplify the denominators using the rationalizing factor. See an example here. 5 divided by root 2 root 3 minus root 2. So this is one of the problem. Let me solve this one, how to rationalize the denominator. Here I'm saying rationalize the denominator. So observe what is the denominator. 2 root 3 minus root 2. First of all, check it. Is it binomial or not? Yes, it is binomial because it is having 2 terms. Now check whether they are quadratic or not. Yes, they are quadratic. This third order is 2 and this third order is 2. So it is a binomial quadratic surds. Now very simple. Binomial quadratic surds are rationalized using its conjugate. What is the conjugate of 2 root 3 minus root 2? The rationalizing factor is its conjugate, that is nothing but 2 root 3 plus root 2. Now whatever the rationalizing factor is there, we need to rationalize using the rationalizing factor. Now how to rationalize? Now the 5 pi 2 root 3 minus root 2, we will be multiplying and dividing with the rationalizing factor. In order to rationalize the denominator, we need to multiply with the rationalizing factor. Whatever you are multiplying with the denominator, the same thing should be multiplied to numerator. So I am multiplying as well as dividing. So what is the next step? We will multiply numerator with the numerator. 5 is multiplied to 2 root 3 plus root 2, and denominator is multiplied to denominator 2 root 3 minus root 2 multiplied to 2 root 3 plus root 2. Now if you observe numerator, you can directly multiply. 5 times 2 is 10, 10 root 3 plus 5 times root 2 is 5 root 2 divided by denominator. If you observe, it is in the form of identity a minus b into a plus b. So let us use that identity. It will be 2 root 3 square minus root 2 square. So that is equals to 10 root 3 plus 5 root 2, 10 root 3 plus 5 root 2. Denominator, it will be 2 square 4, root 3 square is 3. First we need to do 2 square is 4, root 3 square is 3, so 4 times 3 is 12, 12 minus here square root gets cancelled 2. So that is nothing but 10 root 3 minus 5 root 2 divided by 10. If you observe here, the denominator is 10, which is a rational number. So you have rationalized the denominator. This particular rationalizing denominator is one of the most important concepts you need to know. I think you understood what is conjugate surds, how to rationalize the binomial quadratic surds.